Hello everyone. Today we are going to learn how we can design a logic circuit by using the multiplexer. Here the working of multiplexer all of we know, and the multiplexer we require to use to design a combinational logic circuit. But the question comes, why we are using the multiplexer to design the combinational logic circuits? Here the multiplexer we are using because of the multiplexer having some advantages. From that, the first advantage is simplification of logic expression is not required. It means here when we are using the multiplexer to implement any of the logic circuit, then we not required to simplify the logic expression by using the laws of the Boolean expression. For an example, suppose we have this type of logic equation, and that logic equation is a bar b plus a b bar multiplied by, suppose this is the equation, multiplied by a bar b plus a b bar multiplied by c. Suppose this is the equation. Then to implement that equation, here we not required to simplify it, just we required to implement by using the rules of the implementation for the logical expression by using the multiplexer. So this is the first advantage. We not required to simplify any logic equation, we just required to use it and simplify it. Okay, then the second advantage is there, when we implement the logical expression, we not required to use the many type of the logical ICs. For an example, suppose to implement the equation a bar b plus a b bar, for this equation we require to use, if we are going to construct this the logical diagram for this equation, then we just require to use one OR gate. After that, here we require to use the AND gate, and we also require to use the NOT gate. For the OR gate we require to use one IC, for AND gate and for NOT gate also we require to use the ICs. So for that purpose, here we use these various ICs, but this same equation can be implemented by using only one multiplexer IC, and for that here we use one multiplexer. That multiplexer is 4-line to 1-line multiplexer. If we are using the multiplexer to implement the logical expression, then the IC package count gets reduced. It means here the hardware of that complete logic circuit gets reduced. Okay, so for that here we use the multiplexer. If the hardware is reduced, means here the system cost also gets reduced. Okay, this is the second advantage. The first one is simplification of logic expression is not required. The second one is it minimize the IC package or the count, and due to this here the system cost also reduces. Then the third one is there, and that third is the logic design is very simple, means here there is no complications for designing the logical equation. Later on we will see how we can implement the logical expressions by using the multiplexers and the demultiplexer. In this video we are going to discuss only for the multiplexer, and later on in the next video lecture we will see how we can implement the logical expressions by using the demultiplexer. Okay, so these three are the advantages of the multiplexer. When we use the multiplexer, here these three advantages we got, so therefore here we can easily use for the implementation. Now we will see how we use the multiplexer, what are the steps we have to follow for the implementation of the logical expression. Okay, so here the first step is we have to identify the input variables. if we have the logical expression, and that logical expression is like this. Function of, here f means the function of a comma b. These a comma b are the input variables. A comma b are the input variables. If the equation is like this, function of a comma b comma c, or it is function of ABC, function of ABC, it means these three are the input variables which we are using for the implementation. Then the function of a comma b means function of AB equals to summation of minterm. Here this sign is for the summation. Summation of minterm, m stands for the minterm, in bracket 1, 2, 3. Here the input variables we have to identify. In the procedure, the first step is we require to identify the input variables, available input variables in the logical expression or the logic expression. The input variables we have to identify, and it can be identified from the equation. We are considering this equation, function of a comma b means the two input variables are there. Okay, means here the input variables are only two, means we can decide the required multiplexer. Here the multiplexer we are using for the implementation of that logical equation. So we are going to identify how many number of input variables are there. The input variables means the input we are going to apply. That input is applied at the select lines. Where we are going to apply? We are going to apply it to the select lines. So if the input variables are 2, A and B, it means here the select lines are the two select lines, and from that select line we can recognize what type of multiplexer we require to use, and it is given by using the formula, and that formula is 2 to power m equals to n, where n are the input data lines. N are the input data lines we considered in the multiplexer, and m is the select line. That select lines are the input variables. Okay, so only two input variables are there. It means here the multiplexer we require, that multiplexer is 4:1 line multiplexer. The multiplexer is the 4:1 line multiplexer. If the equation is like this, function of ABC, function of ABC, it means function of a comma b comma c, means three input variables are there, means m is equals to 3. It means the multiplexer we are using, that multiplexer is 8 line to 1 line multiplexer, or you can say it is 8:1 multiplexer. Okay, so first step is we require to find out the available input variables, then we can decide the multiplexer required. Okay, after that here we have to identify the decimal number corresponding to each mean term. What its meaning? We require to identify the decimal numbers corresponding to each mean term. Means here we have the equation, and in that equation here the decimal numbers are given. For which line they correspond? In the multiplexer there are the input data lines. Here first we draw the multiplexer, and that multiplexer is supposed to be the 8:1 multiplexer. Here this is the multiplexer. The multiplexer having the input data lines. These input data lines are D0, then last one is here D7. Okay, the second line is D1, then next one is the D2 and up to the D7. Okay, here at this side we indicate the output, and that output is the output Y, and suppose this one is 8:1 multiplexer. For 8:1 multiplexer, we require to use 3 number of select lines, and these 3 select lines are S0, S1 and S2. Okay, these are 3 select lines. These select lines we are going to use. Now, whatever the numbers are given here, we write down the number 0, 1, 2, and this one is the number 7 number. Okay, so we require to identify the lines which are given in the equation. Okay, means the first line is there, means the first number is there, 1 number, 2 number and 3 number. Okay, the 0 line is not given, first one is given, second one is given and the third one is given. Okay, means here we require to identify the number corresponding to each minterm. The next one is what? The next one is the main procedure is here. We require to connect the given input lines to the logic 1 level. Given input lines to the logic 1 level. Whatever the given input line is there, whatever the corresponding number to that particular line is there, that we have to connect to the logic 1, and the remaining input lines we require to connect to the logic low level. Okay, so this is the procedure we require to follow for the implementation of the logical equation. Okay, so we will see some examples on it. The first example we have, that example we already considered, and that example is here the one sentence is given in that example, and that sentence is the question is implement the following expression using the multiplexer. Implement the following expression using multiplexer. Here first step is we require to identify the number of input variables. I am going to write down here at the left hand side. Input variables I am considering that are the input, and inputs are the 2. Which are those inputs? A and B inputs. Okay, these are the input variables, not the data inputs. Okay, now the second step is we decide the multiplexer. These input variables are nothing but the select lines of the multiplexer. So the multiplexer having the 2 select lines that we require to use. Okay, means the multiplexer which having the 2 select line, that multiplexer we can use for the implementation of the given equation, given logical expression. So the multiplexer we are going to use, that multiplexer is the 4 line to 1 line multiplexer, because here the 4:1 multiplexer having the 2 select lines. Then after that, here what to do? Just we require to decide what corresponding numbers are there for the minterm. It means here the given numbers are the data lines from the multiplexer that we require to connect to the logic 1. Where we are going to connect? We are going to connect to the logic 1 level, and the remaining input lines we require to connect to the logic low level. Okay, means here first we select the multiplexer, and where from select the multiplexer? From the input variables. So here while solving the example, while designing the logical expression, while implementing the logical expression, we just require to use the input variables and the given data lines or the given digits, given number in the example. Okay, so I am going to solve it. So for that, here we require to draw the multiplexer. Here is the multiplexer I am going to draw. The multiplexer is, which multiplexer we are using? We are using the multiplexer, that multiplexer is the 4 line to 1 line multiplexer. The multiplexer which having the 4 number of the input lines and only one output line. So in this is the block which we are using. Now the input lines we write down inside this, and the input lines are how many? 4:1, means the multiplexer we are using, that multiplexer is the 4:1 multiplexer. This is the output line Y. At this here, at lower side, we use the input lines. That input lines are nothing but the input variables. So here is the input variable A, and here it is the input variable B. I'm going to write down the A1 and the B here. Okay, so we require to show the data lines here. So 4 input lines means the data lines are there. So the first line is the D0. Here for D0 we write down the digit equals to 0. Then second line is the D1. So for D1 we write down 1. Then third line is the D2, and for D2 we write down 2, and here it is the fourth line, that is the D3 line. Okay, so these are the 4 input lines. Then what is there? There is a one more extra input, and that extra input is what? It is the strobe input or the enable input. This strobe input or enable input is the active low input, so therefore we connect it to the ground. Okay, now here the 4 lines are there, one output is there, that output is the Y output. These lines are the data line from D0 to the D3. Okay, these are the 4 data lines. That 4 data lines we have to connect to the logic 1 and the logic low as per the given steps in the rules. Okay, so what is the next step? Here connect the given input line to logic 1. Connect the given input line to the logic 1 and remaining lines to the logic 0 or the logic low. Okay, so here in example 1, 2 and 3, these lines are given, and the remaining line is the 0 line that we have to connect to the logic low. The 2 logic level lines we have to draw here. So first one is here, that line is the logic low line. Here this is the logic low line. Here I am going to write down the 0, means logic 0. This line is the logic low line, logic 0 line. Then the second line is the logic high line. Here is the second line, that line is the logic high line, means the logic 1 line. Here is the line logic 1. This one is the logic 1. This is the logic 0 line. Okay, the given inputs means 1, 2, 3. Where is 1? This is the line 1. This 1, 2 and 3. This we are going to connect to the logic 1, and the remaining one is connected to the logic low. Okay, so here the logic 0 line we connect first. So this is, we have to connect to the logic low. This is connected to the logic low, and this line we are going to connect to the logic 1. Means here this is connected to the logic 1. The second number is connected to logic 1, and third one also connected to the logic 1. Okay, this is the implementation of the given equation. Okay, means here the given equation is there. From that given equation we have to find out the number of input variables. Then we decide what type of multiplexer we require to use. After that, here we find out, we identify the corresponding lines given in the equation. What are the input lines given in the equation? The given line we require to connect to the logic 1, and the remaining line we require to connect to the logic low. Okay, so very simple designing of the combinational logic circuit by using the multiplexer. We will see one more example by using the multiplexer. Here the example is function of a comma b comma c. Function of a comma b comma c equals to summation of minterm in bracket 0 comma 2 comma 4 comma 6. Okay, this is the equation which we have to implement by using the multiplexer. So what is the first step? The first step is we required to find out how many input variables are there. So I hope you understood what are the input variables. A, B, C are the input variables, means the input select line. So 3 number of input variables. So we require to use 8:1 line multiplexer, because 8:1 line multiplexer having 3 number of select lines, and these 3 number of select lines are the input variables. Okay, then the lines we require to decide which lines are given in the example. So 0, 2, 4, 6 means these input lines. D0, then D2, D4 and D6 are given, means 0, 2, 4 and 6, these are given. So these lines we require to connect to the logic 1, and the remaining lines, which are those remaining lines? Remaining lines are 1, then 3, then 5 and last one is the 7. These lines we are going to connect to the logic low line, okay, or logic 0 line. Here I am going to draw the multiplexer. That multiplexer is the 8:1 multiplexer. So here we are using the multiplexer. That multiplexer is 8:1 multiplexer. That multiplexer is 8:1 multiplexer. So here this is supposed to be 8:1 multiplexer. Here this multiplexer having 8 number of data lines. So we need to show the all 8 number of the data lines here. Okay, so this is the multiplexer which we are using. Inside this, first we require to write down 8:1 multiplexer. But before drawing the diagram, here we must write down one sentence. The sentence is, as 3 input variables are there in the given logical expression, so we require to use 8:1 multiplexer. Okay, so here 8 number of input lines we require to draw. So here first line is the 8 number 0 number line. So here is the 0, then first line, then second line, then the third one, then fifth one here, then sixth one, 7. Okay, so here I am going to write down the digits. 0, I am using the other color. Here it is 0, then first, then second, then third, then fourth one, then fifth one, then sixth one, and last one is here. That last one is the 7 number. Last one is the 7 number. Here is the 7 number line. So these are the total number of input lines. These input lines are we call the data lines. These are the input data lines. Then next one is what? The next one is we require to draw here 3 input lines. These input lines are the select lines. These input lines are we use for the applying the data. These inputs are A, B and C. So this is the A, B and the C. Here one line is for the output. So this line is the output line, and the output is the Y, and this Y is the function of the A comma B comma C equals to minterm. Summation equals to summation of minterm 0, 2, 4, 6, means instead writing Y here, we can write down the letter, that is the f function of a, b, c. Okay, after this what to do? Just we required to use the logic one line and the logic low line. Okay, so the lines which are given in example, that lines we connect to the logic one. So for that, here we have the two lines, that two lines are the logic one line and the logic low line. Okay, so we require to use the two lines here. These two lines are the logic low line and the logic one line. So here I am going to draw these two lines, logic low and the logic one line. Here we use one line for the logic low. So here is the logic low line. One more line we require to use, and that line is for the logic high line. Okay, means the logic one line. To connect the inputs to the logic low line, here it is the logic low line. Okay, and this one is the logic one line. You can interchange it. You can write down for the logic low or the logic zero line. Okay, so here it is the logic high, means logic one line, and here it is the logic low line. Okay, so first we connect the inputs to the logic high. The given inputs we connect first. So first one is the logic 0. Here I am going to connect the logic 0 line. Then the second one is the logic 1 again. It is connected to the 2 number. Then fourth number we connect to the logic 1 here. Then 6 number we connect to the logic 1. And last one is the 7 number. Last one is the 6 number. Okay, only 4 lines are there. The remaining lines we require to connect to the logic low line. So first number is not given, we connect it to the logic low line. Third number is not given in example, so we connect it to the logic low line. And fourth one we connect to then the fifth one, and the seventh we connect to the logic low line. Here is the fifth line, we connect it to the logic low line. Okay, so first number, third number, fifth number and seventh number, these lines are connected to the logic low line. If you draw this diagram, then you make sure where you are connected, that point must be a bold or the dark point. So here I am going to make one dark point. Here it is a dark point, so it indicates there is a connection. Okay, so here again the sixth line I am going to make it a bold. Then here the first one, then third one here is connected to the logic low line. Then the fifth one and last one is the 7 number. It is connected to the logic low line. Okay, these are the input variables a, comma, b and c. One more thing we have to do here, and that is we require to use the strobe or the enable input. This input is the strobe input. That strobe input we connect to the ground. Here we can write down G oblique E, means strobe input or the enable input. Okay, so in this way we can implement any logical equation by using any logical expression by using the multiplexer. One more example we will see, and in that example the truth table is given instead of the logical expression. Okay, so in that truth table it is given that the input variables are given. The input variables are a and b. Here the output is given, and that output is the y output. So input a 0, b 0, output y is equals to 0. Input a 0, b is 1, output y is equals to 1. Input a is 1, b 0, output y is equals to 1, and last column a is 1, b is 1, output y is equals to 0. This truth table is well known for us. What type of truth table this one is? Which gate produces this type of output? The XOR gate produces this type of output. Okay, so we can implement the function of XOR gate by using the multiplexer. Okay, so how we can solve? Here just we compare the given table with the multiplexers truth table. Okay, so this truth table having the two inputs A and B, means the multiplexer we require to use, that multiplexer is the 4:1 multiplexer again. Why 4:1 multiplexer? Because 4:1 multiplexer having the two number of input select lines, and here again the two number of the input variables are there. Okay, so here we write down the multiplexers truth table, and it is like this: S1 and S0, and here is the output Y 0 0. Here we get the output Y having the D0 line. Okay, the output line selected, that line is the D0 line. Then here it is 0 1. Here we get the data line selected, that is D1. The next one is 1 0. The data line selected is the D2, and last one is 1 1. That time the data line selected is the D3 line. Okay, so here the input we consider that inputs are A and B instead of S1 and S0, right? Y is as it is, but instead of D0 there is a 0 1 2 3. If we consider the example, okay, means we require D0 is equals to 0 when A is equals to 0 and B is equals to 0. We required D1 is equals to 1 when we apply the input A is equals to 0 and B is equals to 1. We require D2 is equals to 1, means here instead of this D1 output, the output is equals to 1. Okay, then we required the D3 is equals to 0. Okay, so for that here we require to use the 4:1 multiplexer. So we draw it on the next page. Okay, so here we draw the multiplexer. That multiplexer is 4 line to 1 line multiplexer. Here is the 4:1 multiplexer having the output, and that output given in table is equals to Y. The two input lines we draw here, that input lines are not the input data lines, these are the select lines. We consider the input variables. Here we apply the input A and B. Okay, and one more input is here, that input is the strobe input. We connect it to the ground. Okay, I am going to write down here G/E, strobe or enable input we can say. The 4 input lines are there. These 4 input lines are D0 to the D3. Here we write down it is the 0 1 2 and 3. Okay, so as per the given equation, given truth table here, in that truth table the first and the second and the third line we require to connect to the logic 1 because their output is equals to 1, and these two lines we require to connect to the logic low. Okay, means here the first line and the last line we require to connect it to the logic low. Okay, so here I am going to connect these two to the logic 1 and the other are to the logic low. Okay, so this is the logic 0 line, and here this one is the logic 1 line. Okay, given lines, the first one and the second one number and the 2 number I am going to connect to the logic 1, and these two are connected to the logic 0. Okay, this is the implementation by using the multiplexer. Okay, next time we will see the implementation of the logic equation by using the demultiplexer. Till then, take care.